This is the Amp Hour Podcast, released December 16th, 2018. Episode 420. An interview with Joe Long. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Joe Long from HackerBoxes.
Hey, Joe, how you doing?
I'm doing great. How are you?
Good. It's good to talk to you. We first met in person, at least. We'd talked on email once, but we met at DEF CON this year. You were actually at the vendor area there. So what were you doing while you were there?
Yeah, we were doing a lot of things at DEF CON this year. Met a lot of people. I really liked your blimp badge with all the million LEDs on it. So yeah, we were there. In the vendor space, we had several of the prior HackerBoxes. I think we had 11 or 12 that we were selling, and we were selling a badge, and we were also sponsoring the hardware hacking village and the soldering village. We had made up a bunch of
that's great
kits and soldering things and little badges and little Ethernet taps and things. So we were having a great time there, as always.
Yeah, that is like dialed into the community there. It seems like so. What, for people who don't know, what is HackerBoxes?
Okay, well, HackerBoxes is it's predominantly a monthly subscription service. So a lot of people are familiar with things like Loot Crate and Birchbox and Blue Apron, where you get some stuff in the mail in a box every month. So it's kind of physical stuff, whereas we're used to having things on the internet in this day and age. So our stuff that you get, though, instead of being toys or food, is
I was going to say, is it edible, the stuff that you guys are selling?
Not usually, but they're items related to,
Okay.
to electronics and hardware hacking. So, electronics kits and tools and, supplies that electronics hobbyists would like solderless breadboards, jumper wires, alligator clips, all that sort of thing. So, the sort of thing that you can normally, a lot of us buy these things on eBay or Amazon, but, to just have them curated and pop up in your mail every month. And, of course, we get a little bit of economies of scale. So that's predominantly what we are as a subscription service. And, there's an educational component to that. So when the stuff comes in each box, there's generally a project or two in there that we kind of hint at how to do it and, give some links, and then people work on them together and share questions and things like that. And then we also sell past boxes. So we generally have them going back about a year. You can buy the hacker box from 4 months ago or something like that. And then we have some very specific things like, workshops that are like, we have a thing called a starter workshop that's like an introduction to electronics, and it comes with a soldering station and multimeter. So for people that are just kind of digging in.
Yeah, that's great. It is specifically targeted kind of at the security industry as well, or just kind of broadly targeted?
Not particularly. We do some things that are somewhat security oriented, just, because our name is HackerBoxes in like the broadest sense of hacking, meaning, trying to do more with less, and, getting into things and figuring out what they do and using them for other things and expanding their application, sort of like in the the MIT Tech Model Railroad concept of hackers from this Stephen Levy book. Because of that name, we also because we do things like DEF CON, we always take the chance when we can to touch on things related to security and security research and things like that. So.
Yeah, that makes sense. And I really like that too about the sometimes when you just have something show up and, so I work with people who are getting started in electronics too. And a lot of times they're like, well, what's my first project? I don't know what it should be. And when instead it's like, well, here's some stuff and here's some general ideas, it's much better to have that in front of you. And then you can use that as a starting point. You start to investigate, well, what is all this stuff in the first place? Where do I actually go from here? So are people normally getting started kind of with HackerBoxes?
We kind of run the gamut of sort of skill and experience level. We certainly have some members that are relatively new. I mean, we kind of say it's not completely an introductory thing. You know, we kind of jokingly say, you know, if it's your first time at Hacker Boxes, you have to solder. Like if it's your first time at Fight Club, you have to fight. And, you know, people have said, nice. Oh, well, could you make a Hacker Box that doesn't have soldering? And I was like, if that accidentally happened, we would change that box so that it had something in it you had to solder. So that, you know, and we,
right.
You know, but for one thing we do, I think, you know, a lot of electronics, the way we all learned it in school is it was very theoretical and mathematical. So we try to take that out of things, you know, whereas we just kind of, because that's what I think is great about projects like the Arduino project. You know, basically people just get a board and plug it in and just start going at it. And I think that sometimes that's a lot cooler, you know, than trying to sit there and, you know, figure out the matching impedance first before you can even go in the lab. So, exactly. A lot of our stuff is like, here's a bunch of stuff. This is how you solder it together. This is what you can do with it. And of course, you know, we're hopeful that people will do that and then maybe back it up a step and be like, well, hold on, why does that work? Or more the case, why does it sometimes not work? Right. So, yeah. So, you know, and we've all been there. So.
Yep. Well, yeah, and exactly. And the, you know, if someone is like, hey, I'm really interested in electronics, you're saying that they're gonna have to solder. That's fine. I think some people probably use that. That's like a barrier for them, but that sounds like you push through that. But then it's like, if someone says, I'm interested in electronics, where do I start? And you pull out a calculus textbook, it's like, oh, okay. Now what? You know, like that's a tough, but it's like you said, like that's how a lot of schools right. kind of start things out. And so instead of having the hands-on, I mean, people who listen to the show will not be surprised that you and I jive very well on this kind of thing. So there's nothing surprising here for people who listened to the show before, but it's I like the experiential.
Exactly. And that's what, to me, that's the hobby part of it. That's the, you know, getting into it and having fun. And, you know, I mean, I'm an engineer. I used to teach engineering. I'm all about the theoretical part too, but I think that, you know, the theory is meaningless without the practice. And I think the hobby is actually having fun and doing stuff. Not many people do math as a hobby. Not that doesn't happen, but, and I'm really fond of saying, you know, making the analogy that if you had to be a mechanical engineer and be able to, you know, analyze strains and temperature curves and all these things before you could drive a car, no one would drive a car. That's not real life, you know?
That's right. Yeah. Right. Well, so let's step back a little bit. So you started in engineering, but take us up to the point where you started doing Hacker Boxes. How did you get to where you are? You were born on? No, I'm just kidding.
When I was born, I was very young, and I was really very wet. Sorry.
So you were practicing engineer for a long time, right?
Right. Yeah. So I was kind of one of these people who was like kind of a techie my whole life. I mean, way back in the 80s, you know, I was an Apple II person on BBSs all the time and all that sort of thing, you know, pre-web. And then, you know, I studied engineering and I was an engineer for a long time. And then I took a diversion in my career for a while. Not exactly a diversion, but I kind of branched out into patent law, which is, you know, actually in a way just another aspect of engineering, just has a legal aspect to it. And I kind of missed working on things, and I was still doing things as a hobby and, you know, working with my clients on the technical aspects of their legal problems. But you know, I really like the hobbyist aspect. And so, you know, I did this idea just popped into my head one day about doing a subscription box. And so that kind of started as like, it started as a hobby. It was extension of my, you know, even though I am a licensed engineer and I've done electrical design work as a living, when I was working almost entirely only in patent law, doing electronics was almost like a hobby. So an extension of my hobby was, so let's, you know, get these kits together. And part of the idea was, driven by, just working with some people in, you know, in the maker community and noticing that, you know, despite some really great resources for getting toys and stuff that, you know, the parts we needed to do our hobbyist work, there are times when you're like, oh, I just need a 10K potentiometer. And it's like, you know, you don't want to wait 2 weeks and pay $8 in shipping to get a 50-cent part shipped. And I was like, so it originally started with me thinking, oh, let's make a club, like a buyer's club where we all build up our parts catalog. And it grew a little from there.
Right. Yeah, exactly. To build up the lab, you're saying, right?
From there, that because kind of I basically, you know, realized when we started digging into it that, you know, people didn't want to just get like a stack of resistors and, you know, they wanted each box to be more of like, well, you know, what can I do with it? So we kind of, it's still something between those two things. You know, there are still just supplies and stuff to put in your junk box that come in the box. But you know, there's also usually sort of an application or a theme to every month's box.
Got it. Well, let's walk through one of the boxes, because that's kind of interesting, and like what people would open up and see in there, because it seems like there's multiple projects, but you've probably seen what people actually do with them as well. Like,
yeah, well, and that's what's really interesting, and that's part of where I said that it runs the gamut, because for beginners, for people that are just kind of like getting into the hobby, they seem to just do exactly what we say you can do, and sometimes are not even able to pull that off because they'll short something out, or something won't work out, or they'll be missing a certain thing that they might need to make it happen. But they'll just kind of jump in and get going on it. But there are other people, the more advanced people might get it and be like, oh, I already have, like, for example, in the most recent box that shipped, there was some little audio amplifier boards that use the LM386. Well, people that have been doing electronics for a while have a bunch of different LM386 boards and circuits laying around. So there are probably plenty of people that looked at that and they were like, well, yeah, I already have one of those, and they just threw it in their box, So and there are certain things that are meant to just be thrown in the box. Like, for a few months, we just included like every imaginable different size of shrink tubing, and in little, like 20 item bags and things like that. Just go in your box. And of course, the people that are on the newer end of the spectrum are like, what am I supposed to do with these rubber tubes? Because they're looking at it like, an analogy we use a lot. So on one end of the spectrum, you have a thing that's like, a model car kit. So you buy a model car kit that makes a 74 Camaro or whatever, and it only makes that Camaro. It doesn't have extra wheels in it.
Right. If you have extra parts, you're doing something real wrong.
Exactly. Right. So we say at one end of the spectrum, there's the model car kit model, where all it does is make that car. And if you want to try to make an airplane out of it, you're going to be in big trouble. You might as well just get out a block of wood and start over. Right. And on the other end of the spectrum, there's Lego, where a Lego kit can be used to make whatever it makes, like a pirate ship, but you could also use those same exact blocks and make a spaceship. And that really what you probably do is both. You get it and you build what's on the cover, maybe, but then you throw them in your box and you use them for later things. And we say that Hacker Boxes is a little more on the Lego end of the spectrum, meaning if when you get the box, very rarely is it something where you just put all the stuff together and they all go into one thing and do something. So and we have had comical things like that shrink tubing thing where we just get a bunch of people that are like, I can't figure out where to put the rubber tubes in my whatever the main project was that month. It's like, no, you just put them in your supply box, right? So Right, but yeah, right. So and it's pretty cool. Like, what we really like, we have a whole bunch of like filters, like kind of like mental tests that we run before we greenlight a design. And one of them is, will this appeal to lots of different people? Like, will a new person or someone with less experience, or even someone who just wants an easy way out, just be able to put something together and use it? And on the other hand, is this going to be of interest to someone who's already done this 5 times and just wants to have another one to keep on hand? So, yeah.
Yep. Yeah, that makes a lot of sense. Yeah. And it's cool too. I mean, like, I really like that idea of like just having the extra stuff in there, because I was remarking on Twitter earlier this week of like why do people like unboxing videos, right? Like, we see all these people like do mailbag, like Dave, my co-host, does a lot of mailbags, and people seem to love those. And I watch other channels, and like I love them too. And I was perplexed why I like it. And ultimately, it's because I'm building up a mental library. And what you're talking about is almost building up just a part library and like building this thing out. You don't know you need this thing until you really need it. We all become
right.
Hoarders eventually, and so you're kind of just helping feed into that a little bit, but in a positive way.
And like. And on that note, like, we our online material, we call them the box guides. They're basically just like information about each box. We've had like I think it's around 500,000 views on those. And as much as I would love it to be the case, we do not have 500,000 subscribers. So what that tells me is that there's a lot of people that look at these things just to be like, hey, what are these guys building? And I think that's a that's a great thing about this sort of stuff. That's why we put that stuff out, to be completely public, because it's, it's such an amazing sharing opportunity to, like, we've had boxes where one of the items in it were like, well, what can you do with this thing? Well, watch this, EEV blog about what you can do with, I think particular, we linked when we did a FPGA board, because there's David made some really great videos about what is an FPGA and what do they do, because so we were just like, so watch these videos. So, we kind of link out to lots of other stuff, and people link to our stuff, and it's, it's a really good sharing. Yeah, exactly.
That's great. Well, let's walk through some of these. So you do all your documentation on Instructables, which is cool. And so you said the last one was audio, and I'm just kind of like going down the list here. So audio, and then before that was Jumbotron. I assume that's lighting up a big sign. or something.
Yeah, that's right. We had some of the little panels that are used to make up the big jumbotron screens.
Oh,
So
cool.
they're
Okay.
little 32 by 64 LED panels,
Nice.
and then a driver circuit and a little kind of game controller that you can use with that.
And then before that was Electrochem. That's like, like it looks like a bunch of sensor breakouts and things like that.
That's right. Yeah, and actually, this was somewhat inspired by the I don't know if you saw it at DEF CON 26, the Florida Man's breathalyzer badge.
Oh, I did see that. Yeah, that's good.
Yeah, so we were looking at that, and someone was like, "Hey, you should make a hacker box with a breathalyzer in it." And I was like,
That's a
"Done."
good idea. Yeah.
so you can kind of see from that was month. Basically, that came up just shy of 2 months ago.
Right after.
So you can see how long our cycle is, right? Because know that means that what we were designing in July, late July, early August, we were able to get that out November, because that's a question a lot of people always ask us is if I give you an idea right now, when will I see it? Well, maybe like 4 months from now. So unless there's already a blockage in the pipeline. And that actually brings up an interesting point that I'd love to share, that nowadays most of our box ideas at least at their very initial origin come from member and public suggestions.
Really?
So we'll get someone will send us an email, or we'll be talking to someone and they'll say, "Hey, you should use a box that has for example, a breathalyzer circuit in it." And we'll be like, "Oh, that's a neat idea." And then we'll just kind of let it sit around and
roll around in the brain for a while,
stew up.
Yeah,
exactly. And we have a big list we keep whenever someone shoots us an email. There are some people that are really prolific, and they'll send an email with like 8 different ideas in it, and and of course, because lots of people are sending in ideas, of those 8, usually 6 of them will already be on the list somewhere. But
sure,
right. We'll
add
how
they might fit together too, and that kind of
exactly,
idea.
Yeah. And so so the initial ideas are often now like we barely even have the ability to even come up with ideas anymore, because basically any idea we could have is already flying at us from the public, which is amazing.
That's great.
We love that.
That's
I know, a lot of people have asked me at times, they're like, "Can you guys keep coming up with these ideas?" And it's like, if we wanted to not have any more ideas, we couldn't do that. Like just so much good stuff is out there, great projects and people sharing cool ideas, like you said, one big happy family, right?
Well, that's great. That's great. I mean, and looking at these different boxes too, it seems like there's it's either like there's a box where there's like one big item, and then there's a bunch of small things around it, like you said, like the tubing or other breakouts and wires and push buttons, stuff like that. How are you actually determining? I guess you don't have to reveal your numbers, but like you do have a limit on how much stuff you can put in there. So like, how are you determining how much stuff to put in, and how are you sourcing this stuff too, I guess?
Yeah, that's a really great question. We actually, it's really complicated. Actually, there's what would a mathematician call it, a multivariable constraint system going on, where there's there's the constraint,
because you're trying to make a project, not just maximize the amount of crap you put in a box. You're trying to make a project first and foremost. Yeah, to some extent, but in some boxes there are two kind of unrelated things that just that, and maybe we connect them by a theme, but that theme was after the fact. It wasn't that we, so like, for example, the Locksport box, which is incredibly popular. It has a practice lock, one of those translucent locks in it, and then a set of lock picks. And then it has a bunch of electronics for making your own kind of demo physical security system, with like motion sensors and RFID input and things like that. Yeah. And
those two things, while they are thematically related, they have no connection to each other at all, right? So, I guess they do a little bit, but we just
I mean, just generally, hacker type sneakers type stuff, right?
right. So but as far as the the multivariable constraint problem, I said there are some of the constraints are very like they're you would almost say they're easy, because they're firm physical constraints, and those are each box has to be under a pound so that we can ship it easily and cheaply.
Oh, right. Okay.
It has to fit within like a general box shape, which that's a little bit more flexible. But like, for example, we've had things we wanted to do that were a little like longer. So like when we did a Yagi antenna, that box was a little longer. The one with the Jumbotron was a little longer, but we can't really go over like 10 inches, because then we'd have to use a super thick box or a tube to store it. So there's a volume constraint, like a physical dimensions constraint. There's a weight constraint, which the weight constraint is a really hard one. Like there are projects we'd love to do that, but the weight constraint hits that. And then obviously there's a budgetary constraint, and then there's the educational requirement, and then there's the coolness requirement, right? So, and those last two, we can, there's a lot of flexibility there because, if you had the right, I don't know what you want to call it, like a quantum physicist or someone doing the discussion, you could make a toothpick incredibly interesting by talking about all the atoms in it, right? So I mean, in electronics is kind of
right. If you go low enough,
electronics is kind of like that. Like we can try to make anything as interesting and as cool as we want, and if it's not that cool, we can add some cool swag like a koozie or a wool hat. If you look at some of our last couple boxes had those, and we always have lots of stickers and stuff. So we can try to make anything kind of cool, and we can try to make anything educational. So those are kind of easier constraints. But on the other hand, also we need to, we like to have very, very different themes.
Right. You don't want someone to open and be like, oh, this again.
Right. Exactly. And so, and some of those things we can just never deal with, like, like we need microcontrollers in most things. Like, probably 2/3 of the boxes have a microcontroller in it, and probably half of those times we just use an Arduino type of thing, often a Nano, because they're small. And we've used the ESP32 a few times just because those are popular, and
you get a lot for your money.
Exactly. And so there are things like that get repeated. We have USB cables. Probably every other month we throw in some sort of different USB cable. But for a while we were just using kind of the same USB cable over and over again. And then we were like, well, let's make them a little bit of a nicer USB cable. Let's make them different lengths. Let's make, one rugged and one light, to kind of mix it up. So that's an example of something that's almost like an annoying requirement, is that, in an awful lot of boxes, we have to have DuPont jumper wires and things like USB cables and alligator clips. But in part, that's what the Starter Workshop is all about, is, we kind of have this sort of philosophy that we assume you have the sort of things that are in the Starter Workshop. So, if there's a specific box,
like a power supply, it looks like some diagonal cutters, a multimeter, one of the soldering irons that will burn your house down.
Right.
Servo.
So there are times where we're like, oh, in this box, oh, there's no room left, or there's no weight left, but we're going to need some male-to-male jumper wires. And sometimes we're just like, well, people probably have those, and if they don't, they'll go find some. So, we can't put everything in all of them, and actually we sort of avoid trying to do power supplies just because, we do have a fair number of international subscribers, and they can't use wall wart power supplies. We, really shouldn't be shipping any sort of batteries, plus they're heavy. So like we never really do power supplies. We assume you've got those, or you can figure out what they take. And, and that's part of the, some people might call it annoying, but it's also part of the educational part. So like with the Jumbotron, that thing needed a very specific type of power supply. And it's like the online conversations we saw from, quite a few people that were like, well, you say it has to have 4 amps. I don't understand. What does that mean? And so, well, now all of a sudden you have to learn about power supplies, and that's a good thing. So
right. Yeah. And so it seems like a bit of community has sprung up around this. So what does that look like for you guys?
Yeah, there's quite a few people that every month, almost seem to want to build it as fast as they can and then post a picture of it on the, on the Instructable or on Facebook. And yeah, I mean, there are a lot of people out there, and interestingly, a lot of the community is just really quiet. Like, they'll occasionally shoot us an email, or it's really funny when we get an email from someone and they're like, I've been getting hack boxes since box number 3, which at this point means they've gotten, well over 30 of them. And, I just wanted to ask about yada, yada. And then, we'll notice, oh, wow, that's the first time we've ever heard from this person. Like they've been with us for that long. So yeah, so there's a lot of really quiet folks out there, but, there's a lot of people that have made videos, and people that, almost always post pictures of their projects. So, it's a good community.
It's great. And I think that shared context kind of matters too, of like being like working on the same thing, right? So you can have, it's like if you say you have a problem with just a random web thing and you go to like a Stack Exchange, if it's a completely unique message, you're screwed. You're not going to find anyone who's like, you either got to go and describe it and wait for responses and hope for all that stuff. If you find you have a completely similar problem because you're in a completely similar situation, that's a much better scenario, in my opinion, for learning and for finding out.
Yeah,
things.
We definitely see that all the time. And it even helps us because there's no way, no matter how good your QA department is, you can't test out every single scenario and every different type of laptop and every type of serial cable. So people email us and they'll say, oh, I can't get this and this to work. And, a day or two might go by where we're like, oh, let's try to set that up. Let's see if we can make that break. And then someone else will email like with almost exactly the same question, but they'll have some other little clue in there that makes us realize like, oh, that happens when you don't have when you're using the 5-volt pin instead of the VN pin. Oh, now we see. And so the fact that a bunch of people are hammering on the thing all at once, it's almost like a built-in quality assurance.
Right. It's scary because there's a bunch of people doing it, but it's also helpful because a bunch of people are doing it.
Yeah, and we have if you look through our box guides, there's always a little note at the beginning of the box guide. There's like a list of what's in the box and then what other things you will need. Which usually just says soldering iron, but sometimes it's like you'll need this type of battery or you'll need a computer or something like that. And then we were always like, you also have to have a good attitude and a spirit of like adventure, because this doesn't always work. And the point isn't necessarily to make it always work. Like if, we sometimes have
if
to.
Dave were here, he would say, I hope your project doesn't work. He likes saying that one a lot. So
yeah, exactly.
I will repeat that in his stead.
Yeah. And I agree with that so much. Like you learn so much more from that. I think that, there is the, mm-hmm. there is the desire to like, to win. Right. But on the other hand, sometimes you almost learn more by losing. And I wanted to find, what is this here? Let's see. Yeah. So one of the things in our FAQ are, what if I mess a project up? And, it says the goal is progress, not perfection. You'd better plan on messing things up. We all do. The more components you burn up, short out, or otherwise mutilate, the more you're learning. The path to expertise in electronics is beset with smoking heaps of gear and dreadful tangles of spaghetti coding cables. That's the way it is. Right, I mean,
right. Until you know the smell of burnt capacitor, you've not truly
exactly.
learned.
Yeah, you're being too safe if you're not occasionally messing something up.
Right.
So.
Yeah. Well, what about that? I mean, like on the safety side, you guys worried about that for people getting started, things like that? I mean, sounds like it's mostly USB power.
Yeah, I mean, we try to be really careful about just giving the necessary warnings. I mean, granted, electricity can be kind of dangerous, but, we don't do any like super high voltage step up. We don't have and even things like, we've done a few different things where we have relays, and so, of course, it's obvious to the trained eye that, oh, I see, here's a board, here's an ESP32 board and and a relay. I could use this to, Wi-Fi control my lamp. Well, we always have a thing in there that's like, no, you better use it to Wi-Fi control your audio speaker, hook up, your line level voltage, because
something 5 volts, please.
Exactly. Or, unless you know what you're doing. And if you know what you're doing, you don't need to ask, you don't ask us. Right. So it's, and of course it's all kind of like, use at your own risk sort of thing. But, we try to take the risk out. I mean, ultimately what we want people to do is have a good experience and learn things, even if they completely botch up the project, that, they'll hopefully learn something from wondering why they botched it up, right? But we don't want anyone to hurt themselves. So.
Of course. And so are you seeing people kind of combine past boxes together to do other new things? I mean, like it sounds like there's a lot of people doing the suggested project but then they're taking it further.
Yeah, definitely. And we actually also suggest, a lot of times we'll kind of describe something simple you can do with what's in the box. And then we'll be like, you could also do something like this or this or this or this, or what else can you do? And just see what people come up with. And, and it's awesome. People do really cool things. And, and of course, people that have been HackerBox members for a while, which a lot of people have, we have a lot of folks that have been members just for a long, long time. And they have they have a whole bunch of HackerBox stuff now. So, when they get something like, like for example, the Jumbotron, a bunch of people added the chemical sensors from the month before to that and made it so that, so one guy had it so that the Jumbotron floated around in his pool and had to use the thermocoupler from the month before to measure the temperature of the water and show it on a big display. And people just combine things like that all the time. And it's really neat. I mean, to some extent, it's kind of the point of it, right? I mean, it's kind of like what we were saying with that Lego model. Like if you get the pirate Lego ship, you better put some cowboys and police officers on there too, right? So.
Yeah, I'm headed back to my hometown for the holidays, and I will be specifically playing with the pirate Lego set with my nephews that I had as a kid. Nice. And so I'll be doing that. It'll be a pirate spaceship, of course, right.
Yeah, I have 3 sons that are on the oldest one is 7, and they love building things and they love Lego. So, in my mind,
nice.
That's what
are they getting into the electronic side of things, or is that a little bit?
They're pretty, they're pretty young, but it's kind of funny how they they all, especially the 7 and 5-year-old. I mean, less so with the 3-year-old, but they all already know like what an LED is, and they, if someone were to tell them like, oh, watch out for that light, it might be hot, they would definitely be like, oh, LEDs don't get hot. It's like they just
that's great. Yeah. Well, that's the other thing I was thinking about earlier is that these kind of things where people getting started, a lot of the getting started resources, people credit Arduino and other things, Raspberry Pi, things like that. I see more and more engineers coming up be like, yeah, that's how I started. That's how I get into it. Of course, before that, there was, anyone talking about the Forrest Mims books and the 555 projects in there. And, there's always these resources that are the beginner stuff that ultimately ends up flavoring a lot of engineers' experience over time, because you get those, like I was talking about the dopamine hits, like when you get that thing to light up, when you get the Jumbotron to show the pool temperature or whatever it is, it feels good. That's great.
Yeah, it is. It's this awesome feeling of like mastery over the physical world. Like, oh, look, I hooked some stuff up.
I wield electricity. I bend it to my will.
like for me, back when I was younger, I took a ham radio class when I was really young, and it was like kind of my first exposure to electronics. But I often kind of explain that my one of my really exciting things about electronics is, when you're a little kid, you think your dad is God, right? And I remember being probably 5 and asking my dad how a radio worked, and he couldn't explain it. And I was like, oh my God, he doesn't even know how a radio works. It must be so hard. And I felt like I set my my goal on becoming like this, what in my mind as a 5-year-old seemed to be like an insurmountable level of genius to be able to explain how a radio works, which of course, now to me is an absurdly simple concept.
Well, I don't know, man. It's still pretty magical to me. I don't know what you but.
Yeah, well, I mean, but the thing is, though, now we've got to, I expect my son by the time he's 12 to be asking me what spread spectrum is,
exactly.
Why, what's a software based radio versus a
they do tend to zoom right past
or something, right? But exactly, yeah. But it's it's funny how something will just stick in your mind as like, oh, that must be really important because people don't know it, or that must be really tricky, or it's almost like magic, and then it just gets stuck. Whereas I think there are other people that look at things like, let's say, for example, just like how FM radio works, and they think, oh, that's so mundane. There's one of those in every car. Why would I care about how that works, right? So it just depends on what sticks, like what. So, I mean, one could argue from our educational mission that what we're trying to do is just get things to stick, like for people to mess around with these things and be like, oh, I see how a signal can be represented as a list of numbers or a voltage, or, oh, that's interesting. And then, who knows, maybe 20 years from now, someone who did that will, work on some next generation AI or something like that. And,
definitely.
We could only hope to be humbled to know that, some people that bump into our product will be inspired by it. So,
yeah, I think that's the goal of education in general. You keep saying we. How big is the HackerBox's team?
Well, right at its very core, like at its design core, it's only a handful of people, but we have a whole bunch of support things in the periphery. So, like for example, we pack so many boxes now that we have a pretty large team of people that help us put the boxes together, and some of those people are also interested enough in the box that they'll get one and play around with it. Some of them are just people that are, it's a fun way to make money to put stuff in boxes. They don't even really seem to care what it is. But so, it's always the gamut. But so, we have a lot of folks in the kind of the physical, I guess you would call it like box fulfillment part of the business. We're always trying to expand the other areas. We're trying to have more and more people do what we kind of internally jokingly call it like a guest box design, like where someone, is like, oh, I have an idea about this. And then we'll say, oh, hey, lay out the PCB and tell us what. Yeah, well, not really celebrity. I mean, not that we'd be opposed to that.
No,
if you want to have
no,
a Chris Gamble box.
I was thinking like SAR or Dave.
I would actually
or
say,
like that,
Well, I would actually say that one cool thing that we did was we sponsored the Badge Life badge competition at DEF CON 26, and we did it by giving hacker boxes to all the different levels of winners, and there were many different levels, so lots of people got them. But the overall winner, one of the prizes they got, which we were a little bit tongue in cheek about it, but we thought, no, let's see. We told part of the prize was that you could design or contribute to a future HackerBox. And it turns out that the person who won that has been, we've had several phone calls now about,
that's great.
Some different things. And they've given us some input on, so, they designed this beautiful badge. Do you remember the Illuminati
badge?
I do.
Oh, that was a gorgeous one. Yeah. Yeah. I didn't meet who that was. And I know some people don't like I don't know if that was a a nondescript personality doing that, but I didn't meet them.
It was I mean, I know them as a person now, but it only has their handle on it publicly, I wouldn't say their name, but yeah, it was a beautiful badge, and it was very cool, and it was it had like a nice backstory to it, that it was like inspired by
Nicolas Cage, I'm sure,
older family member who was a Mason, something like that, or or it was either that or Keanu Reeves, I'm not sure,
right,
but so anyway, the so we've been talking to them now, and they've been giving us some great ideas about some future projects. So you never know when, these like I said, it's an internal name that we call them, where it's like a guest designer. So so that's kind of fun.
Cool. Well, on the sourcing side of things, so like how are you normally sourcing the actual components? Are you mostly doing like an AliExpress, Alibaba type thing, or like, I mean, because we don't really know what I don't know what your quantities are. Like, I don't know how you're not running down to like Micro Center or something, right?
No, definitely not. So we actually ran into a problem really early on, like around month 3, where if you go to, so most of the things that you see advertised on like AliExpress and even to some extent on Alibaba, they're not the manufacturer, right? They'll make it look like it is, but it's really, agent. Or what I think, they're in Shenzhen, they call them a trading company. So they're companies that you just, you want something and they'll go buy it, or they'll buy some stuff on spec and then sell them. But generally for some specific thing, so let's just say some certain type of cable or some certain variant of like or let's say Arduino Nano board or something, there's a company that makes it, and there's really just one, even though like it looks like 100 different people sell it, right? So so if that company that makes it only has 300 in stock and you need 3,000 of them, you're in trouble, right? And then if they're even like, well, we can run some for you, well, that's going to take a few weeks. And then if they go to do that, and then a week into it, they find out they can't get the the ATmega chip for it because they just can only buy 2,000 of them right now, then you're in trouble, right? And so we realized that there's a real problem when you get into larger quantities. You can't just get on AliExpress and buy them, right? It just doesn't work that way. So we actually have a buyer that we work with in Shenzhen who basically they're, how I told you that there's these kind of interleaving multivariable constraint type of things. Well, they work with us on those constraints to help us, like we'll pick something out and they'll be like, well, we can't do that. And then we'll be like, well, what about if we use this different type of interface? So actually the board that we're, the box that we're putting together right now, we had to go several rounds on that. And actually, I don't want to talk about that one specifically, but so let me take a few steps back. And the box that we did that had the Yagi antenna in it, it has a little USB Wi-Fi thing.
Which number is that? Needed,
I'll have that up in front of me. It was 23, called Airwaves. Cool. So the thing with that was we needed an inexpensive but highly functional small USB Wi-Fi adapter that had an SMA connector. So that was vitally important because we needed to interface to several different antennas. So that box has 5 different antennas in it. So we just, and part of the point of the box was to experiment with how these different antennas, what the trade-offs were with, omnidirectional, directional gain, the distance, things like that. So, so obviously it had to have an SMA connector. Well, most little, kind of commercial Wi-Fi devices and dongles don't have an SMA connector. Right? So, the antenna is either integrated or, it might be
it's like an onboard chip antenna or something like that.
Yeah, exactly. So we, or
UFO even.
So, I remember and I remember that one specifically because when we were going through the purchasing process on that, I was traveling. And so there was a lot of flipping open the laptop and like looking at different things that are, half written in Chinese and, pictures from some different angles. And then, having it cracked open so I could see what chip was in it. And, and then kind of going around and around and around and, getting one where, okay, look, we're going to need them in 2 months. We're going to need this number of them. They have to fit this size, weight, and cost constraints. And, and so having someone on the ground there, obviously who speaks Chinese and knows all these different manufacturers it's just absolutely necessary. Yeah. Like if we didn't have someone doing that, we would be done.
So, well, that's cool. That sounds like an interesting process.
Or I'd be on a plane a lot and I don't speak Chinese.
Right. So, you learn eventually,
Yeah. Although interestingly, my last name is the Chinese word for dragon. So I think sometimes when I deal with these Chinese companies, they're like, oh, he's the dragon.
I would like you to please record that interaction next time and verify that with me. Yeah, we'll see. Oh no, it's the dragon.
Well, that's been an ongoing joke for my life because, when I was in college, I worked, and I know you and I both used to live in Pasadena, right?
I used to work out there. I never lived there.
Yeah. Okay. So, so when I was in college, I worked at JPL and, which is obviously part of NASA. So you'd think, oh, that's part of the federal government. But the lab I was in I think everyone other than me was Chinese. And so, and then when I worked at Georgia Tech, one of the research labs I was involved in that did optical communications, I was one of the only people in the lab that wasn't Chinese. So, and then in all of those different contexts,
you should have learned Mandarin by now, man. Come on.
I should have. I wish I could. And, I need to get one of my kids to take it in school so they can teach me. But
there you go.
Yeah, so it's been an ongoing joke in my life with all these Chinese people who I've worked with who have been, overall extremely amazing people. And I've loved working with them that, they always end up joking that that I'm the dragon. So
that's great.
And I think sometimes my personality matches that. So no, I'm kidding.
Nice. That's great. So, I mean, it sounds like you, what would you say? I mean, is this your full-time gig or no?
No, it's not. I what I call my day job is I'm actually a patent attorney. I'm an IP attorney.
Well, I wanted to talk about that as well. And I think that is quite the interesting mix. I mean, I know you said that earlier on too, that you got to kind of back into this because you wanted to get with the hands-on thing, but it's, to go from hacker boxes to IP law, it's quite the interesting mix there.
It is. And, I'll tell you, one of the coolest things about it is it really gives me an opportunity to see such varied aspects of our field because, as an IP attorney, generally we're dealing with large companies that have very valuable IP interests that they have to protect, to not be in, in malfeasance against their shareholders, right? They have to protect the value of their IP. And, and contrast that with the things we do in the maker hobby world and even with hacker boxes where we're like, everything is free. If we design something before we even finish designing it, we'll send you a copy of it.
IP, I remember this from somewhere. What we were going to do with that.
So it's, and it's interesting because it's really, I feel like it has put me in a really unique position to appreciate the importance of those different seemingly contradictory mindsets, that I think, if you want to get philosophical on a grander level, reflect, some important aspects of our society that, we still live in a relatively capitalistic society where we're driven by keeping score of, what product sells and what doesn't. And, who makes more money from what thing, and we vote with our dollars and things like that. We live in a capitalist society. On the other hand, we have to take care of each other, especially when it comes to things like those in need. And when it comes to things like helping people grow, like helping education, and open source is a lot about educating people and making resources available that help people. Right. And, I would say, I know a lot of people, especially in the open source world, don't love Microsoft or Bill Gates, but I mean, he's a perfect example of someone who profoundly wealthy, but has set his resources towards doing good things for a lot of people without necessarily any personal income.
Post Microsoft, Bill Gates is a very different.
Right,
it feels like to me.
Exactly, he's a tremendous philanthropist. Yeah. Right, he's inspirational. Right, so I think that to me is a model of you can play a game, you can fight and try to win and score the most touchdowns or home runs or whatever. You can play the game, but then you can also be a decent person and contribute to the people around you and kind of have that open source, open hardware hacker mentality about life in general. So I think it's really cool. I mean, I'm really into that.
Well, let's hear about IP law is something we've touched on here before. I think we've talked about it. I mean, obviously we're big fans of open source around here, and we've talked about some of the, there's some shenanigans in and throughout the IP world. But I'd love to just hear about how you got started with that and the kind of work you did, kind of like a real look at what it looks like day to day. Because I think I think pretty much at this point we've started saying unless you have the millions of dollars to litigate a patent, why are you even doing it? As a lot of people were listening here, and but maybe that's not correct. Maybe that's a misconception.
It's correct and it's not. I actually always start there. So when someone calls me up and they say, "Oh, hey, I've invented something and I want to get a patent," I always start down the road of no, you don't want a patent. What are you going to do with the patent, right?
Right.
Because it's kind of I'm thinking of buying a TV and maybe even a couch someday. I must buy a house. It's like, what, do you really need a house? You sure you don't want to rent a house? You sure you don't want to live in a trailer? Like,
right.
I
Yeah.
mean, you know what I mean? And it's not, that's not a totally apt analogy, but it's important to understand. And of course there's the vanity aspect to it. Some people are like, I just want the patent. I want my name on it. And I can appreciate that as well. But, but when it boils down to it, patents are expensive and they're kind of a business thing. They're not something that like, they don't have a lot of meaning for like an individual person. There's something you use to protect an asset so that you can sell it, right? So, and I love, and I think I'm not alone in this for people that do, what we call kind of, IP, what we call intangible property. So in life we have real property. That's our house, right? So like land, and then we have
atoms, atoms instead of bits or legal documents.
Well, but there's actually two things under that heading, because then we have personal property, which are like your laptop and a book you might own. Sometimes that's also called chattel, right? So those are physical things, but they're not real or royal property like land. And then there's intangible.
What was that word again? Chattel.
Chattel, like, just means stuff, like items, like
never heard that word before.
And so we call that personal property versus real property, right? So your house is real property, the couch inside your house is chattel or personal property, and then there's intellectual property, right? So if you write some code, you own the copyright on it. Or just to keep it simpler, if you push the button on your camera and take a picture, you own the copyright on that picture. You own it the very second you created it. So a copyright's a very simple form of intellectual property. Not that it's not important and valuable, but it's created instantaneously, right? And there's also simpler forms of trademark, which are like the when you put the little TM on it, that's the common law trademark. It's an unregistered trademark. Unfortunately, there isn't really a simple form of patents, but when you publish something, you're kind of short-circuiting other people's patenting. So in that regard, you can play in the patent world just by publishing things or creating open source.
Because material. Then that would act as like a prior art that they couldn't necessarily patent that.
Exactly right. It's a barrier to other people patenting something once someone has already published it. Right. It's basically giving it to the public domain. So
cool.
So there's these different types of property, and I love analogizing between them, right? So because inevitably people that are kind of in our world, and by our world I mean people that are kind of like in the kind of the hobbyist electronics, the maker world, we like to make stuff where we're really interested in sharing things, and the all one big happy family motto once again. We sometimes people in that world, are like, oh, these damn patents, we don't want any more patents. These just make everything difficult and expensive. And not that there's not some truth to that, but it's like, you have to analogize that. Yeah, it'd be really nice if we could all just go anywhere and I could just pitch a tent and sleep anywhere I want. But you don't want me doing that in your mom's front yard. I take it like the fact that, even if you don't care about your own personal real property, you probably don't want, your elderly relatives to have to deal with like vagrants coming and setting up on their land. Like we do have some value in property law. You don't want someone else just jumping in your car and driving it away. You don't want someone squatting in your backyard. And, equally so, if you create, an innovative invention that passes all of the bars for becoming patented, the useful, non-obvious requirements, and you get a patent on it, then it's your right to control that property to that extent. And not that there aren't, as you say, shenanigans that go on and under those headings, but it's like I said, it's a tough contradiction at times for someone to be as pro, open source and sharing and maker community hacker mentality as I am, but then also to be helping people protect their IP. I will say that I like to say that I stay kind of on the nice side of IP. I help people get their patents. I don't generally go around getting involved in patent litigation and having people use patents as hammers, especially in the context of what we call a non-practicing entity, where someone just buys up patents, never intending to use them.
The rest of us call them patent trolls.
That's right. Yeah. In the legal world, we call them non-practicing entities. Yeah,
that's nice.
The common term for them is patent troll. And there's that's not entirely an unacceptable thing to do, but it's not particularly useful.
Right.
Like it's not adding much to the world to be doing that sort of thing, right? So. So that's not really what I do. So
right. I mean, the thing I look at is like, so patents are usually the thing it's a return on the R&D dollars that someone spends. So a company goes and spends, $5 million to hire engineers and build prototypes and do all this stuff. And then at the end of it, they have an indenture that they want to protect. It's like basically the IP, like you said, it's a saleable asset basically at the end of that hopefully they can use to either sell it to someone else or protect so they can make money on that $5 million they invested. Like from that perspective, I think it's great. The patent trolls are usually more like, well, I saw this as a thing that, yes, it was, maybe I even paid the $5 million or whatever the company thought it was worth for the patent, or they acquired it somehow, but then they are going to extract more value. And value is a loosely held term in my mind, because it's really, they're just using it to, like you said, use it as a hammer. And that's the unfortunate piece.
Right. And the really unfortunate thing is when you start looking at what, some of us call these things nuisance lawsuits. So a patent lawsuit is a very expensive thing to get involved in. So let me make a simpler example. Let's say I was a really annoying neighbor of yours. I could frequently file lawsuits every time you walked across my yard for trespass or whatever, demanding $200. Right now, of course, I'm gonna have to pay several $100s to file that complaint, and then you're going to get served, and then probably rather than hiring a lawyer and taking a day off of work to go and argue my silly case, you might just be like, Joe, here's your $200 check, go away. Right. But now, puff that up into the world of patents where, just to get started, just to have a few meetings with a patent attorney, you're already talking about tens and tens and tens of thousands of dollars, if not hundreds, and then it will eventually grow into millions. So, if you go to a company, a larger company, and you have even a colorable argument that you might have something that was infringed, and you file a $100,000 lawsuit, there is a fair chance that company is just going to pay that off, and they're not going to mount the battle about it, right? And if they know that you are well funded and you have good attorneys, that sort of thing, that the nuisance can get big enough that it actually starts to become a problem. And then I don't know if you've ever watched the show Silicon Valley, but
I was just going to say season, and I just looked it up. It's season 4, episode 7. That's a great example.
Yeah, and I love that show. It's so real and so ridiculous at the same time. Yeah. I absolutely love it. But the whole thing about where they're like, we were going to settle for this amount, but then someone else settled, and now the case is worth more. Things like that. Like that's kind of those games are ugly, and no one really benefits from those. Like, you're not really helping the world. And like I said, to some extent, they're not entirely wrong, or there would be sanctions against the attorneys doing them, and people would fight them more. I mean, it's not like they're out and out, illegal or corrupt or whatever, but they're just not incredibly useful. And so, and of course, there's none of this is all that black and white. I mean, there are some things that are very black. Like, you look at it and you're like, that nothing sounds good about that. But, often there is an inventor behind these things. So, like, I have seen some situations where there's something that looks like a patent troll, but it's actually like a company that does this a lot. But then, the actual inventor still owns half of the patents, and, the money that's coming out, they're being compensated for, inventing the intermittent windshield wiper there. So there is some righteous purpose behind it in some instances, but the system is not perfect, unfortunately. And whenever you have a lot of money on the line, things can get a little ugly. And like I said, I really like the I kind of consider myself a technologist first, and then a lawyer second. Not that they can really be ordered like that, but I really love teaching. That I think that's sort of my natural role in life. And on the side of the game where you're helping people get patents, it's really kind of a teaching job, because the patent has to teach the invention to multiple audiences. It has to teach it to the patent examiner, and then other inventors, and then maybe even at some point, if that patent ever becomes part of a lawsuit, it has to teach it to the finders of fact, meaning the judge or the jury in that case. So, so there's a lot of teaching that goes on in writing a patent and arguing patents. So that's the part of the job that I really like. And I love working with inventors and meeting different folks who have invented different things, and talking to them about why they invented it and why they felt there was a need for it and what they're going to do with it. It is just really cool stuff.
So let's do a little teaching here. So what does the patent process look like then? So if someone in our audience has been working on a thing, and they came to you and they say, Joe, I want to file a patent, what are the steps that you're going to walk them through to get from A to Z?
Yeah, well, I already kind of told you. The unfortunate part is I will initially first try to talk them out of it.
Okay, that's a great first step, though, right?
and really, what I mean there is, it's not that I'm talking them out of it, but I want to know that they have a good reason for wanting to do it, or they are at least very cognizant of the the risks and the risks and rewards and the timeline and the costs involved
Sure.
before they just blindly go into it.
And what I mean,
and
what
I will
if,
say,
if,
I am.
if you're able to say, like, what are some of the timelines that people should expect? What are the costs that people should expect?
Well, yeah. So let's say we get past all of that. Then so then the process is generally you disclose your invention. We call it a disclosure meeting. It really just means you tell the patent attorney about what your invention is, and you want to be able to get into, you want to be able to focus, like do a course defined type of thing. Like you want to be able to tell the patent attorney, I've invented this, and spit it out in one sentence, right? I invented a car with 6 wheels instead of 4, right? Like,
great. Let's keep using that example. That's perfect. Yep.
Yeah. So, and then you want to say, 4-wheel cars, sometimes one of the wheels gets stuck, or, the differentials are complicated to make. I don't even know. I'm just making stuff up. But so you have a reason why there was a need in the art. And we actually use that term all the time, a need in the art of a 4-wheel car. And so that motivated me to make the 6-wheel car. I had these ideas. My ideas were not obvious because they had the unexpected result of when I added the 2 extra wheels, my fuel efficiency went up, right? So it's really important to have that unexpected result, right? Because anyone who wanted more wheels on a car would simply go from a 4-wheel car to a 6-wheel car. That's what we call in the patent world obvious. And you never want to be obvious. So, you want to tell your attorney, this is what happened that made me think, wow, this is an invention. I've really invented something. Because just doing something new for the first time, what we call being novel, it's necessary but not sufficient. Something does have to be novel, but no one. So an example I make all the time is if you put a microwave oven in the back of your car, in the trunk of your car, and say, I've invented a microwave car, you didn't invent anything. You took 2 things that already existed and you put them together. It's obvious, right? So it's novel. Maybe no one's ever done that before, but which is necessary, but it's not sufficient because it's not. It is still obvious, right? However, if you do that and it increased your fuel efficiency, that was an unexpected result. That's not obvious, and that's an invention, right? So that's a little bit of a subtlety there.
But what if you have a baked potato now in your car? That's not obvious.
Well, but in a way it sort of is, because if you wanted to have hot baked potatoes in your car, if you asked someone who knew what a microwave oven was, which is pretty much everyone now, hey, what's one of the ways I could have a hot baked potato in my car? It's what's called obvious to one of ordinary skill in the art. So anyone who'd cooked a baked potato before would say, hey, you know what you could do is put a microwave oven in there, or they'd say you could put a hot plate in there. Those 2 solutions would be obvious. Right, but it would not. So
do you guys actually run those? Do you run those as tests? Like, how do you actually validate that as the attorney?
Yeah, absolutely. So so there are 3 things that you need to get a utility patent, which is really what we're in the technology world. When we talk about patents, we mean utility patents. It has to be useful, novel, and non-obvious. Those 3 things are required, and we run just like with any other legal problem, you have you have these tests that you run and you make sure that all the elements are met. And so usefulness is a very low bar. Like pretty much everything's useful in some way or another. Like if you don't meet the usefulness bar, you shouldn't even call the attorney to begin with. That's something we don't need to argue about that too much. So novelty just means no one's ever done it before. So no one's ever stuck a microwave oven in the car. Non-obvious means it does something that wouldn't have been obvious. It accomplishes something that wouldn't have been obvious. It's not an obvious solution. So we run those 3 tests all the time. And then there are some other tests, like you can't patent mathematics, you can't patent a process of nature, things like that. We call those 101, or are they patentable subject matter to begin with? So in any case, we do run these tests and we discuss them with the clients, and then these are the bases for which the patent office rejects them. So let's go back to our procedure here. So you tell the attorney, this is what I've invented. You give them kind of the this is why it's kind of unexpected. This was my aha moment. This is why it was needed. Then they could do a search for you. So let's just put that aside for right now, that there's this whole topic of searches. I can talk more about that if you want, but that will tell them whether or not you're barking up the wrong tree. So let's say they do a search and it doesn't look like there's any prior art that's going to be a problem. You go ahead and file they'll still have to prepare a patent application. This is the expensive part of it. That generally costs in the $8,000 to $15,000 range, depending on how complicated the invention is. And then you review it, sign off on it. There's a bunch of legal documents that get signed. They file it in the patent office, and then you wait around for 1 to 3 years. And then the patent office will assign it to an examiner who is themselves a scientist or an engineer. This person knows that field and they work in that area all the time. So they know all the art that's in that area ostensibly. And then what they will do is reject it. And I know that sounds like I'm making a joke, but they reject like 98% of patents get rejected on the first shot.
Holy crap.
And it's not, it's definitely not the end of the game, but really what it is if you think about it, let me reframe the issue of getting a patent. The patent office is going to, this idea that you have for doing something, they are going to take that idea away from the rest of the country for 20 years. right? And just let you do it. Okay, that's a big deal.
Yeah,
so they are,
it's like an exclusive license, right?
Exactly. It's called a limited monopoly. Is exactly that. Exactly like a license. Yeah,
that's an interesting way to look at it.
So they're going to take it away from everyone else. Well, they're a government employee, so they work for everyone else too. So they are required to give what's called, an argument or a reason for allowance, right? When you get your notice of allowance, the patent is finally allowed. The examiner will go through and explain why you have to, why you should be given this patent, why you should be given this limited monopoly, right? Because it's a big deal. They're taking it away from everyone else. And it's important to remember that. So I like to frame it that way. And really what you're doing is that examiner is going to say, nope, you don't get a patent. This is the prior art I found. And they'll cite the closest art and they'll make an argument. Sometimes it's not an excellent argument. Let's just leave it at that, as to how that prior art proves that your invention is either not novel or is obvious, right? And then really what they're doing is they're saying, I am going to have to give a very well-reasoned and excellent explanation for why I'm stealing this idea, not stealing it, but precluding the rest of the country from getting to use it and giving it just to you. Write that argument for me right now, right? That's really what the rejection is. They're saying, here's the prior art I found, now you fix it. Right?
Oh, interesting. So it's like a bounce back at that point.
Exactly, right. So they're not really saying no, they're not saying bad dog, no patent for you. Really what they're saying is, okay, it looks like maybe you don't really get a patent. Explain to me why you do, right? And usually if you make a good argument, also at that point you can change the wording of your claims a little bit, what exactly it is you're claiming you own, as long as you're not offending the description in your application. You can change the words around a little bit. You can make what you're claiming to own a little narrower. You can, move it over a little bit, as long as, like I said, you have to stay within your initial description, what we call the specification. So that goes on, and sometimes that can go many, many, many rounds. Sometimes it just goes 1 or 2 rounds. In 2% of the cases, it goes no rounds. You just get an instant allowance. That's pretty rare. And if that happens, you probably claimed your invention too narrowly if that happens. But one could argue the opposite.
Does that mean that's not a good patent then at that point?
Not necessarily. It might be that it's really good. It might be that it's just super narrow, that it's like, I invented, this thing that has this, and this element. There's so many elements that it's just a tiny little thing, right? So the interestingly, with a patent claim, the more words are in the claim, the less you own, right? So if you think about it, if your claim says, so the claims are these sentences at the end of the patent that are sort of like, to make an analogy to real property again, they're like the meets and bounds. That's at the front of a deed. Those kind of mathematical things that describe.
It goes this far deep in the lot. These are the corner points. That kind of idea.
Exactly. So the claims of a patent are the meets and bounds of the invention. They define legally what exactly the invention is. So if your claim says, I invented a thing, right? Well, great. You just owned everything, right? So because it has very few words, so it's extremely broad. Okay, so that's like where if you say I claim a computing machine, well, that's incredibly broad. But if you say right. I claim a computing machine that is liquid cooled, uses 3 logic levels, where one logic level is represented by 3.3 to 3.35 volts. Like, that's so many words that you're describing something very, very narrow, right? It has to use a trinary numbering system. They have to be confined to these voltage levels. The voltage levels have to be defined by this type of, a CMOS transistor or whatever. And so once you say all of that, you are owning very, very, very little, right?
So does that mean that a broader patent, if it is awarded, is more valuable?
Exactly. Yes. Sense. Except for the cases where it's so broad that you should have never been allowed it, because then it'll get re-examined and it'll get torn apart later.
Let's just call that shouldn't happen. If it does, it's a fluke and it might be bounced out anyway.
Yeah. Right? But so part of the trick that we do as a patent attorney is, you'll describe your invention to me in engineering terms, and then I will write claims that try to capture it as broadly as possible. Right. So that you end up owning a lot. So even if you're thinking, I invented this thing that does whatever, and it has these type of transistors, I might describe it as having like switching elements or, a non-linear circuit device that, accomplishes, a bimodal distributed arrangement of electrical values, which could kind of be saying a flip-flop, right? So we just try to describe it as broadly as possible, so that, because what I was about to say a second ago is you don't want people to be able to design around, right? So if you have a claim that uses tons of words and is really narrow, and let's say part of your claim, and we deal with this kind of stuff all the time, your claim says, okay, so it has 3 voltage levels and one of them is 3.3 to 3.5 volts. Well, I could just design mine to always use 3.6 volts. Now your patent does not apply to my product, right?
Oh wow. Okay, it's that like corner casey.
It is, yeah. So what we do is we try to not say anything that's that specific. So we start by using very, very broad language. Like we would never use things like voltage levels, but it might be that the examiner finds art that shows, oh look, this thing has 3 voltage levels, and one of them's 12 volts and one of them's 9 volts, and then we're like, okay, well, what if we go in and say, you know, the highest voltage level is, but you know, then we would still try to make it very broad. Like we would say, okay, well, less than 12 volts, right? To get around the prior art. So really another way, again, I said, I warned you, I love analogizing to real property because we can see it. So when Manhattan was first made, the first people that came in, they owned the big corners. They just took over a big chunk of land, and which later became a corner. And then, you know, decades and decades later, people were buying little tiny pieces of what we call infill. Right. So once an area of technology has been around for a while, like let's say computation or communication systems, you're doing a lot of infill. Like you're no longer patenting a car. You're not patenting a car with 2 axles. Right. You're patenting a tire that can go on a car.
The plastic piece that's in the door.
Exactly. And you're actually like you're patenting things like the shape of the tread and how it wears and how deep it is in the middle versus the side. I mean, you're just getting into these tiny details.
What kid hasn't actually dreamed about growing up to become an engineer and then get a patent about the tread of a tire, you know?
Exactly. It's it can get really sexy. I mean, when you're working on some stuff that's and I would say that's one thing that was, you know, for me was very exciting about working on in patent law is I know, you know, when I first went to college, I majored in physics, and I thought, oh, you know, I want to work on like, you know, radio waves and particles and things like that because I really love radio technology. And then I realized like a physicist will spend their whole lives working on one problem. I was like, I want to be one of these engineers. They design stuff. They'll work on a new product every couple of years. Well, a patent attorney, they work on a new patent every like 4 to 6 days.
Oh,
right?
Wow.
So like I get to learn all about some new piece of technology, talk to the person who invented it, who's usually like a world-class researcher in that area or someone who's, you know, groundbreaking in that field, and learn all about it, write about it. And then 5 days later, I'm on to the next one, you know, and like, you know, for someone who's like a junk food junkie about technology, like nothing could be better, you know?
Yeah. Well, what about the level of depth? Like, how much do you have to dig in? I mean, you're talking to experts, it sounds like. That's super cool. But, like, how much do you dig in? Like, how much do you have to actually grok what's going on? Do you have to, like, understand the actual underlying technology?
You have to grok it in its fullness, if we're going to quote Heinlein. Yeah, you have to understand it well enough to know what makes it, novel and non-obvious, what differentiates it from the prior art, what's special about it. And so... yeah, I mean,
don't you sometimes run into like, you're like, oh, what the hell am I looking at here? Doesn't that happen? I mean, surely that happens to you.
Not me. I mean, who do you think you're talking to here? No, I'm just, yeah, all the time. I mean, all the time an inventor will tell me something. I'll just be like, and then I'll have to go back and I'll be like, what is, and I'll be honest with you. I've been in meetings.
Well, Wikipedia says that this is.
I've been in meetings with another attorney, you know, because, you know, no one's an expert at everything. So like, for example, I worked with a guy for a while who was really sharp and he was a mechanical engineer, but, you know, we did projects together. And I remember being in a meeting with him where the inventor described something. And then the guy was like, so hold on, what is this NPN, PNP? And he wanted to like get into that like it was part of the invention. And I was like, dude, that's well known in the art. Like that's not part of this invention. He's like, and he was like, no, but I know, but what's the NPN? And I'm like, it means it never points in. Okay, let's just move on, right? But it's like, you know, and I'm sure there are many times, like, you know, for a while I worked on some propulsion system patents, and I know I was talking about, you know, like some phase change materials and different combustion things. And I'm just like, I have no idea what this is. And it was probably causing me to momentarily, I hope not, you know, because you rely on the inventor to set you straight, but momentarily get focused on the wrong thing, you know, and be like, oh, hold on. So it's liquid oxygen. And they're like, no, it's always been liquid oxygen.
Right,
you know,
right,
shut
right.
up. And, you know, and then refocus you on the thing that's important. And, you know, but it's why, you know, just like with most things in life, when you operate at a very high level, you become specialized. So like, you know, in the patent realm, my specialties are, you know, communication systems, so radio frequency communications,
cool.
Security, obviously embedded systems, because, you know, anything related to microprocessors and stuff I love. And then there were some things that changed in the patent world around 10 years ago with regard to how software or what we call computer implemented methods.
I was going to ask about that. Okay.
And so that's one of my specialties because, you know, I'm kind of a computer scientist, right? So you know, I know a lot about software, so I just kind of became an expert in how to get around these issues in the computer implemented method realm, and also how to express the operations of a computer implemented system as a process so that it's patentable, because inherently that sort of thing is not patentable, right? And it shouldn't be, but sometimes there are aspects of them that are, and you have to pull out the part of it that's actually the invention that has nothing to do with the substrate, the computer system that it runs on. And so that's sort of one of my expertise, is that kind of getting into the software part of it. So like, I worked on some of the patents for Google Wallet, and also for some of the Bing search linguistic stuff and Bing Maps and things like that. And more recently, a lot of things related to medical data processing, electronic medical records, and then also data analytics around that. And like just being able to really get into the detail of the software of those things, and and being able to speak software language about those things, even though, I don't really consider myself a programmer or software developer, but I studied computer science, in my computer engineering background. So I can speak the language of those things, and I've kind of learned the legalese around it. So, that's one of my expertise, and if someone came to me and they were like, hey, I think I've invented, a new drug that lowers blood pressure, I'd be like, great, let me find a patent attorney to refer you to, because I don't know anything about pharmaceuticals or chemistry. And I can't do that. Like, it just wouldn't be right to the client. And I couldn't, and I don't want to.
Yep.
So.
Well, the thing I always think about with the software patents is, I guess maybe more on the design side. Maybe we could delineate too the utility versus design stuff. But I remember there was one thing about like iPhones and like curved icons. So maybe that was a design patent. But I just remember there was like a whole big hubbub about curved icons at one point.
Yeah, that would be a design issue, because that doesn't really have any utility. Right?
Okay. So then let's delineate. What is the difference between utility and design?
Well, design merely covers it protects how something looks. So it's a pretty narrow thing, because like, for example, if you have a design patent that I don't know much about the icon issue there, but if you had a design patent covering icons with rounded edges, you could make icons with square edges, or beveled edges, like kind of a hexagonal edge, and it would not offend that design patent. So design patents are very narrow, because they merely point out a single way of displaying something. And a utility patent is the broadest type of IP, because it covers the concept behind which something is done. So it's kind of implementation agnostic, especially when you get into processes and methods. Like, I love the computer implementable methods and method and process claims, because it doesn't matter what substrate you do them on. And in fact, I wrote this really great, I'm saying it's great, I liked it, boilerplate that, years ago, that I still use all the time, that where I kind of describe what the idea of a computational substrate is, in order to really draw attention to the fact that when I talk about a computer implementable method, and I say a computing machine, that computing machine could be some gears or some pulleys and ropes, or Tinker Toys. It doesn't have anything to do with it being being a Windows box, right? Like that's not what we're talking about. It's not a computer invention, So there's a great quote from a Supreme Court case where they said that that an invention, if it were otherwise patentable, is not rendered unpatentable because you put it on a computer, right? So I like to turn the tables on that and say, look at this invention. It doesn't have anything to do with it being on a computer. We happen to run it on a computer, and I'm going to, in one of my claims, say that it runs on a computer. But what is a computer? Well, let me tell you some things, and then I list a whole lot of ridiculous examples of what a computer might be.
So could you give us a more specific example of like the thing that's you're actually patenting is on software, but you moved it outside of it? Could you give us an example of what that was?
That's right. So let me make a kind of a Tinker Toy billiard ball example, something that's so simple it almost seems stupid. But let me just try to follow along with it. That let's say just something related to like data analytics. So if you were claiming it so that it were a computer program that took in a bunch of data and processed it, well, I mean, that's like a computer program, big deal. But if what you had is something that receives sampled information, where the sampled information came from a sensor in the environment. That sampled information, reflects these characteristics, physical characteristics of these objects. That sampled information is then filtered, ordered, with a fuzziness of ordering of a certain magnitude, so that 2 is always bigger than 1, but maybe 1.1 is not necessarily bigger than 1. Like you have a plus, an error there. So you're sorting with like a fuzzy sorting, right? And of course, you would use much more technical and legalese language to say that. So basically, you had a forgiving sort, or sorting that was kind of like binned or plus or minus type of sorting, right? And then you use that to create categories, or bins, and then you use those to characterize that data, and then that data was used to accomplish some other output. Like it would tell you, a likelihood of that person having high blood pressure or something like that, right? Like it has to impact the physical world. So we're taking something where we measure some things in the physical world, we do some processing on them we use computer-like terms. What we're really talking about is what is literally done with that data, and then we use it to make a decision that impacts the physical world, right? And speaking more specifically, we say that it has to substantially transform or it has to substantially represent a machine or transform a machine, right? So it actually has a physical connection. So it sounds like software and we're going to implement it as software, but really what we're doing is we're interacting with the physical world by collecting data from it and acting on it. Now you could do that with a bunch of transistors, right? It doesn't have to be software. That's not the point.
Sure. Yeah. It'd just be a much more complicated kind of thing, right? I mean, I guess you are still using transistors.
They're obviously
you have to be more bespoke.
A matter of degrees there. Like, are you literally talking about, doing analog computation with transistors, or are you using a computing machine, or are you implementing a computing machine in an FPGA using a Verilog core or something like that? Like but the thing is, in the end, those substrates should not matter, right? Like if what you're actually doing is something that no one has done before and it wouldn't have been obvious to do, and it's not just pure mathematics. It can never be a pure theory. It has to be something that, that is a machine or transformation that actually impacts the physical world. So
you're saying that the patent is written so that even if you handed a piece of paper to a group of people and they did all these operations, at the end it ended up creating some other number, then changed the outside of that system of people doing that thing, basically replicating a computer.
Right. Well,
is that kind of the idea?
In the end, what you need is you have to have a machine that connects to the real world, right? So if it's all just moving data inside of a computing system, even if that computing system is a table with a bunch of accountants sitting at it, then that's not patentable, right? That's because that's just what people like us would just call pure software. There's no actual invention going on there. But if it's something that you could build with gears or ropes or pulleys, just because you write it as a computer program doesn't make it not patentable, right? So that's where it gets really confusing. And it's I admit that it's very confusing, but that's
I'm a little confused right now, I got to say.
It's it's one of those things where it's the kind of one could call it trickery, but after you do it for a while, you're just like, oh, I can smell the difference between something that is an invention that I could make with physical devices, but I'm writing it as a computer program and I'm going to run it in a computer program. It's a new invention. No one's done this before. Or is it just moving data around? And, and of course, with
so it's just another test that you apply to the actual, whether you should be patenting this thing in the first place.
Yeah. It's
right?
called the machine or transformation test. And there are a couple other little tests that go around it. And, the Supreme Court has commented on this a few times over the last, 10 or 12 years. This has kind of become an issue, and that issue is part of patent harmonization, because in other countries, what we call international patent harmonization, in other countries you can't just straight up patent something that sounds like it's part of a computer system unless it's more physical. So we've moved that way a little bit in the US patent system, not much, because in the end we still have this notion that just because you can do it in a computer doesn't make it not patentable. So and patent attorneys are pretty good at knowing how to word something so that it is actually a machine or transformation. And they also know when it's not. I mean, there are lots of things where a client tells me, oh, I've invented something, and they describe it to me, and I'm like, that is way too much just a big data processing system. Like, if you can tell me how this couples to sensors and what's going to happen to that data afterwards, it's going to, impact, triaging a patient or, throttling a fuel system or something like that, we can talk about this. But if it's just a bunch of processing numbers, then that's going to be a no-go.
So what about like algorithms? I mean, is that a good example of what you would try and apply this test to?
Well, exactly. Yeah. So a purely mathematical algorithm. So let's say like like a fast Fourier transform or something like that. Like, that's not patentable because it's just a.
So is that protectable at all in any way or no? Like if I come up with a new transform type, is that patentable or anything?
Yes and no. So the transform itself is not. So, but generally, but let's say it has a really great application. So let's say you come up with a new thing. It's not an FFT or a Laplace transform. It's some other mathematical transform, but it is amazingly useful at finding very stable digital filters.
Okay,
right?
Sure.
So what you could patent is a method for specifying a filter, and then you might even need to couple that to. Like, you couldn't even say for a signal processing system. You might need to couple it to, an audio transform or something
like, or a
for
radar
like,
system, like this specific
radar
system.
like a communication channel equalizer or something like that. Like, you need to get very specific about I'm collecting, I'm interfacing with the physical world in this way, these inputs, and then I'm creating these outputs. And in between here is this processing that is novel. The processing itself would not be patentable because it's just too pure computation. It's just an abstract concept, and abstract concepts are never patentable. You have to tie them to a machine or transformation. And so it's one of these things where it is a little subtle, but after you deal with it a few times, you're like, I can kind of, I have a sniff test for it, that if it's just purely an abstract idea or not. And, interestingly, it's changed so much in the last 10 years, or not changed a lot, but it's just become a little more specific that, sometimes we do get in a little bit of a debate with a patent examiner on, when they have a feeling one way or another about it that just doesn't jive with our experience. But they've gotten pretty good at, having that same sniff test. And, it's sort of one of these consensual reality things. Like, once everyone sort of agrees that, oh, this is what the transformation test means, and you see it in enough court cases, right? That's American jurisprudence, right? You see the courts are, saying repeatedly, this is patentable and this is not. And in this case,
right. And then everyone goes, let's stop wasting our time by not
right.
Just
yeah.
doing
So,
this up
so
front,
a scary
right?
thing in the patent world, though, is it's so complicated that it sometimes takes a long time and many, many iterations for those things to gel. But, luckily, there's a patent board of appeals for patentability that has its own, that has its own experts. And so we rely on them to give us lots of good examples. And,
would you recommend that, like, the novice engineer, or just the beginner, the novice IP type person, should I be reading patents and to understand more about them, or like what are some resources you usually point people at about patents?
I mean, it's fun to read patents. That it's tricky to read them, though. I mean, I know I was about to say I love, but it would be probably more correct to say I hate seeing newspaper articles or trade journal articles from the technology world that are like, and usually if it starts with Apple patents, blah, 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 I don't even have to look at it because, I don't look at it till the next week when I get in, when I get someone who's just like, oh my God, how could this be? And I'm just like, it isn't, okay, look, there aren't aliens there, put your tinfoil hat away. There aren't aliens. The president is not a lizard monster. Like, it's just all the whole thing where, like, people that have a blind spot, they fill that blind spot in with like a crazy, like 4K image instead of just smoothing over the way your brain does. Right. So it's like, people don't really understand patents. So they're like, oh, this patent talks about, whatever. Apple is clearly trying to patent, nuclear powered contact lenses to kill us all. Like,
right.
No, they're probably not.
Right.
That's probably not the case.
Well, it makes for a good article. Come on, let's start there.
It does, yeah, but it's a little tiring. I'm only pointing all of that out to say that when you look at patents as a non-patent expert, they're confusing. I mean, even these people that write about them all the time, they're usually wrong, sadly, or they've got some little subtlety kind of wrong, and then they build their case around that. Or not their case, but their expose. Like, they've like I said, they're filling in a blind spot with with something very complicated instead of just glossing it over. Yeah. But in any case,
well, I do always like the like the Ben Krasnows of the world. They go and read the patents as like is a way to kind of find out more about, that is the ultimate benefit, right? That it's, you get the exclusive access to this thing, but you also have to share it with the world.
That was going to be my caveat is, you should definitely, if there's a very specific area of technology you're interested in, you should be reading the patents in that area so that you can, but it's, you don't want to go crazy with them because, some of them are going to be written really weirdly. And, in the end, like they're, they might not mean what it seems like they're trying to say they mean. And some of them might just be wrong and whatever, but it's certainly interesting. I mean, I like looking at patents and after you do that for a while, you'll really get a hang of, how they're written and what they say. And then, the next level of, dare I say, entertainment is looking at patents that are what we call pro se patents, where they're written by the inventor themselves.
Yeah,
because the claims are just usually so bad. Even when they're good, they're so bad.
Is there a way to specifically find those, or is there like a site that kind of is a compendium of just the pro se ones?
Yeah, there are some weird, like I can't remember off the top of my head, but they're like wacky patents websites that put out wacky patents, and and a really great I'm trying to remember the name of the. There's a couple of blogs that come to mind. Unfortunately, recently I follow electronic stuff like your blog a lot more than I do the patent logs. But it's like, there's one that's called, I think it's called Patently Obvious.
Okay, yeah, that's a good one. That sounds good.
Yeah, and there's a few like there's a few out there. I mean, if you just Google around like patent blog or funny patents or things like that, you can find some interesting stuff. And and I would definitely say, like, when I talk to people who are like real experts in some area, like a college professor who publishes in some really tiny like area of like MIMO antennas or something, they're usually reading patents in that area, and those patents are often written by they're the inventors are the same people that are publishing at the IEEE journal, and IEEE journals on the same topic.
They're contemporaries, and they're trying to just kind of figure out what's the state of the art kind of thing.
Yeah, and some of those guys read that kind of stuff because inevitably there'll be an expert witness in a patent case related to them or something like that. Oh,
right.
So they'll they keep up with those things. But for those of us who are just like buying the cool new cheap sensor chip that came out and hooking it up to a microcontroller and making a fun project, probably don't need to get bogged down in patents. But I mean, they're interesting. I mean, I think I'm very biased because I deal with them all the time, and I
you deal with them a lot more,
yeah,
right?
Yeah, and I but of course,
so like I have to ask a selfish question here. Is it like, so like I've been consulting and I've had some potential clients ask me about patenting and stuff, and I feel like if I say like the whole thing that you say like about it's not really worth it, then they're not going to listen to me. But especially if it's like a smaller client, how do I nicely break that to them? Is there like some numbers that I can use, like for litigation numbers and costs?
Okay, well, there are a few numbers. One of them, if you go through the funnel, that's an interesting one. So, the vast majority of things that are invented are not patented, right? So like the first step of that funnel is just the guy, so you have an idea, then do you have the $20,000 it's going to take to go through the patenting process? So that's the first step of that funnel. And that's going to knock out like 99% of everything. Right. And then for the patents that are actually filed, probably only something like 70% of them get issued as patents, because they just get along the way, they just kind of get dropped, or they just, the inventor gives up fighting with the examiner or whatever. So there's that's the next step of the funnel. And then there's, let's say you actually get your patent. So we're way down in like a microscopic tip of the funnel now of the patents that actually
and probably
issue.
It's a disproportionately large companies as well, because they paid to keep fighting almost all the other stuff.
Not disproportionately, it's almost entirely.
Oh, really?
Right?
Wow.
So, but hold on. But so now that we're down at the microscopic, this is where it gets ridiculous. Of all those patents that have now issued, which is basically none, only 2% of those ever become part of a commercially viable product.
Whoa.
Right.
Okay.
So like, okay. So
if we started with a million at the top of the funnel, what would be the number at these different levels, you think?
Yeah, it rounds to zero, right? So basically every great idea you have. So that's the thing is when you're talking to someone and they're like, I have a great idea, I should patent it. It's like, first of all, if you only had one great idea, you're not an inventor. You're just some person. Yeah, you're just a guy.
Shark Tank.
I think I forgot a few great ideas, while I was getting the floss out of the container this morning. It's not, it's like so in any case, the ideas aren't valuable. It's their implementation, their business implementation that's valuable. And when you start going down that road, then you want to protect it. So anyway, so just looking at the steepness of that funnel, that should be a big deterrent, right? But then also, so when I was first, I was an engineer for a long time before I became a patent attorney. So I went into law, kind of older. I was an older person. I was in my mid to late 30s when I started practicing law, and I remember the first couple of older, more experienced attorneys I worked with, they never want to deal with independent inventors, right? They only want clients like Microsoft and IBM, the companies that file thousands of patents and have the budget to do it. And they don't want to be handheld. They just write a check and say, file the patent, buy, right? Like those are the clients you want. You don't want to, you don't want to deal with someone who's bringing you their baby and they want to call you every day about it, right? You never want that. And then those are the people that file malpractice lawsuits. So in any case, I was kind of told avoid independent inventors. And then the trick that, I didn't like it when I first heard it, because I was like, oh, that's not cool. But it made perfect sense. And now I kind of get it, is when an independent inventor calls you, you're like, because they always call and they're like, I think I've invented something. I need to meet with you next week. If your answer is, I'd be happy to meet with you in 3 weeks and my retainer is $10,000, please bring a check, or please send a check in advance. That person doesn't call you back. And the thing is, if you end up doing something for them, that $10,000 is going to be nothing. Right. So it quickly tells people this is not a game you want to play. Right. And if they if they really do want to play it, it's typically because they have a reason to play it, and then you're going to know. And I've been involved with some situations where a very small independent inventor had an idea, and they were just really business savvy, and they had a business reason for patenting it to get leverage over another company, or to get a vendor,
right?
To get the vendor or the merchant to be able to make it for them.
I've heard this as well from startups do it as like because if they're trying to get acquired or they're trying to raise funding, it's just something they kind of have to do.
Oh, all the time. I would say of the smaller companies, like the startups I work with, it's all about getting funding. Yeah, it's a way to signal your value. It's value signaling of, look, we've invented these 4 things and we filed patents on them. And, in those cases where they're getting VC funding and the company, it's sort of like a moonshot, like it's going to become amazing or nothing. Mm-hmm. If you become amazing, you need those patents. And if you become nothing, well, you had nothing anyway. So, so in those cases, it actually kind of makes sense. Like, if you're raising, $20 to $80 million and you've got a really steep burn and you're really trying to make something really big, to put $100,000 or whatever into developing a patent portfolio is probably pretty wise, and your investors are going to love it. So that, that's an instance where you want to do it. But, if you're just kind of like a hobbyist or even like a consultant, and you've come up with something that you're like, oh, this is neat, I want to own this. Like you need to think really good about what the ROI is going to be. Like, if everything works out, are you going to be able to sell this or license it to someone, or, and an important thing to remember with patents is they're not a positive right. They're what we call, they're a bundle of negative rights. So they don't give you a right to do anything. They give you the ability to stop someone else from doing it.
Right. You could tell someone else, hey, that's my thing. Don't do that thing. So I have someone who is also going to sue you to do that, not do that thing.
Exactly. So what you want to ask yourself is, let's say it's going to cost you $20,000 to maybe get a patent on something. Is it worth that $20,000 to be able to tell that other guy not to do it? Like, is creating that barrier to entry in your space, is that going to give you a real competitive or strategic advantage? And do you want to go through all the trouble to try to get there? So a really cool thing about our field, or one could say it's a bad thing, I don't know, is that things change so quickly that sometimes patents don't even matter that much, because by the time you get the patent 3 years later, you're on to the next thing, right? So, and that's not the case in pharmaceuticals because the R&D cycle is so long and so expensive. But, in electronics, it's like, I've worked on a lot of patents that I thought were pretty cool. And, 3 years in, when they're getting pretty close to being allowed, they're just like, well, I call the client and they're like, that's what? We're not working on that anymore. Don't waste my money on that, So
that's crazy.
That's going to happen, because we pivot so quickly in the electronics and computer because we can,
That's great. That's great. I mean, I feel like anything that I'm usually working on too, it's, like you were talking about, it's like almost re-implementing of other technology. I'm working on development of stuff, not research of stuff. And it feels like it's more towards the research side of things anyways, where you will actually be patenting things in the first place.
Yeah, and the thing with patents is, as far as I'm concerned, is the the thing that's cool about them is the technology, right? Like it's it's like you want to share this new concept or technology, but the reality of it is that there's so much money involved in patenting, and it's so expensive, and then it takes so much money to enforce patents and things like that the or to monetize patents, that the value in a patent is in its business application, in the commercial implementation, and in the enforcing and monetizing it as a business practice. So it's almost like, the stuff that we kind of geek out on and get excited about, like, oh man, you were able to do that with one transistor. Like that's what's cool. That's what's cool. Like, and that's cool for me when we're in writing the patent and stuff. But in the end, the decision whether to get the patent and whether you really want it, or whether you just have one patent or do 10 children off of the patent because it's so important, all of those are business decisions, not technology decisions.
Right. And hopefully there's business money behind it too, because you're going to need it.
Exactly. Well, and business sense is, business savvy, and not just, throwing things at the wall and seeing what sticks. Granted, the companies that do a lot of patenting, like, IBM, Qualcomm, Boeing, Microsoft, they have the money to just throw it out there and see what happens, So
yeah. Well, Joe, where can people find out more about your law practice and HackerBoxes and you in general?
Well, if you are interested in our law practice, we have a website. It's longtechlaw.com. Long is my last name. Or
the dragon. Don't forget that.
Yeah, the dragon, right? Exactly. Yeah, right. So, or if you're just interested in IP law in general, you can go to the USPTO, U.S. Patent and Trademark Office, uspto.gov, and find a lot of stuff there. But if you have a specific patent or IP question, feel free to call me. I mean, even if that the answer is probably I shouldn't do that. I mean, I'm always happy to answer people's questions, and I talk to people all the time and students and anything. So, that's totally cool. And then as far as HackerBoxes goes, you should definitely check out HackerBoxes. As I know most of your listeners are probably into electronics. It's just our website is at hackerboxes.com. Check out the subscription services and the other fun things we sell, and look at our videos. And like I said, all of our educational material, box guides, whatever extent you want to call them educational, a lot of it just links to other things, but it's pretty well curated. It's all free online. You don't have to actually buy the boxes to jump in there and learn some stuff and try some things out and see what we're all up to every month and get involved in conversation. So.
Yeah, and I'll link people over to the some of the Instructables pages. I have links in my notes about the ones we were talking about, like 26 and stuff
Very
like
cool. that.
So that's a good place to find out more and see pictures and stuff.
Well, where can we find out more about Amp Hour?
theamphour.com is a great place to go, but Twitter as well. And I don't know if you're a Twitterer, but are you on Twitter?
Yeah, we had a bunch of Twitter traffic today because someone took one of the recent hacker boxes and made an ugly holiday sweater with the Jumbotron screen. It's
nice,
not
nice.
Safe for work, but they kind of turned it into like a DEF CON style thing with the DEF CON logo, and it was
nice.
So we actually were having a lot of fun on Twitter this morning. So.
Awesome. Well, thanks for telling us about all this stuff, Joe. It's been quite an interesting journey from the open source, open knowledge stuff to the little bit more closed IP, making money kind of things. It's quite the gamut, like you said. You kept saying this gamut in there. So yeah, it's been an interesting journey here.
Yeah. Well, hey, I appreciate the opportunity to talk to you about these fun things. Well, I wish I could have called in a couple weeks ago. I wanted to talk to you guys about whether or not it was illegal to grab a bird scooter and hack it.
Yeah. We'll save that for another legal podcast, I'm sure.
Yeah, you guys were talking about that, and I thought I know the answer. So, yeah, Dave was right. Don't do that. So.
Okay. All right. Fine. Yeah. All right. Well, thanks, Joe. We'll give you a call soon.
Yeah. Have a great holiday. Take care.